In this video, you're going to continue to look at promise chaining, and we're going to explore a second way we can make HTTP requests in JavaScript. Currently, the only way we know about is via XML HTTP request, but this is not the only way to get the job done. In newer versions of JavaScript, we have access to the Fetch API. This is a different way to make our HTTP requests, and this new API has promises built right in. We are going to need to know about promise chaining in order for Fetch to make sense, but since we already know how promise chaining works, we're going to be able to explore Fetch. And that's where I'd like to start. We're going to start by exploring this new API, then we'll work on replacing XML HTTP request in both of these scenarios. Over in app.js, we're just going to write some standalone code down below to explore this new thing, then we'll worry about integrating it into getPuzzle and getCountry. For now, just pretend it's its own thing. It's like we have an empty file. We access the Fetch API by calling fetch like so. We pass to it a couple of arguments. The first one is the URL. That is the value we would have previously passed as the second argument to request.open, like we do here and like we do up above. Let's go ahead and just get a new puzzle for this little example. So I'm going to fetch right here the URL puzzle.mead.io/puzzle. Now there is also a second optional argument where we can further customize our request. I've linked to the documentation for how you can use this in the PDF guide for this lecture. You can leave it empty for now, or you can remove it completely. I'm going to leave it empty so we remember that it actually exists. Now, what comes back from Fetch? Well, what Fetch returns is actually a promise. We can wait for this promise to either resolve or reject to do something with the data from our request. Right here, I'm going to attach a then method, and what do we get access to for our success handler? We get access to the response. So right here, we can toss response on, naming that argument. Now we'll worry about what goes inside of the response in just a second. We can also attach a catch handler down below. So on the end, .catch, and this is going to catch any potential errors that might have occurred with our request. And all we're going to do for now is name the E argument. I'll call it error. And down below, we will print it. Console.log, printing the error object to the screen. Perfect. So now we have things in place, and we're going to do something with the response. Now in our case, we still want to do something pretty similar to what we did over here in requests.js. I want to make sure that the status code is a 200. If it is, I actually want to get access to the JSON information, in this case, data.puzzle. Now, the nice thing about the Fetch API is that we no longer have to worry about ready state. This promise is only going to resolve or reject when it's actually ready for us. So we know that the request completed. We don't have to figure out if it completed. We just have to figure out how it completed. Did things go well? Did we get a 200? Or did things go poorly? Maybe we got a 404 or a 400 for using one of those invalid query strings. We can access status via the status property on response. So if response.status, in this case, we're going to check if it equals the number 200. If it does, we'll put some code right here to do something with the puzzle. If it does not, in else, we can run some error handling code. Now, when things go wrong, we actually want catch to run. We know that if any of the promises in our promise chain reject, if any of these three rejected from the previous example, that catch would execute. The same thing is true if we manually throw an error from one of the then functions themselves. That means over in app.js, if we want to trigger this catch callback because this else clause ran, we can just throw a new error. That will cause catch to get fired down below, much like throwing a new error inside of a try block would cause the catch block to run in a try catch statement. Right here, we can pick our message, unable to fetch the puzzle. Excellent. Now that we have the error path handled, we can go ahead and figure out how to do something with our data when we get a success with the Fetch API. On response, you have access to a method called JSON. The JSON method is going to take the response body and parse it as JSON. Now we could have done the same thing for the error case down below. In this case though, we're just going to parse the data for the successful request because that's when we know we have the puzzle accessible. Now the catch here is that when we call the JSON method, what we get back is not the JavaScript object. It's actually a promise. and that promise is going to resolve with the object at some point in the future. So this is where promise chaining is going to come into effect. We have two options here. We can attach then on right here, or we can return this promise, adding another then into the chain. So that is the difference between the two examples we had over here. In this one, we attached then on directly. Down below, we returned the promise to add then on to the promise chain. And this second way is the way that we're going to go. So we have response.json, calling it with no arguments. That returns a promise. We are going to return that promise and then add a then call right here before catch. So after the closing parenthesis from the previous then, but before the dot in catch, dot then, calling it and passing in our handler. And this handler is going to get access to the data. So right here, we can name that argument, and then we can do something with the parsed JSON. For example, console.log, and I'm just going to print data.puzzle. To differentiate it from the other puzzles that are already printing over there, I'm just going to comment out these two examples, making sure that we're not printing too much stuff to the console, confusing the output. Let's go ahead and save app.js for the first time. And what are we getting? We are still getting a random puzzle over in the browser. And if the page were to refresh, we get a new puzzle. Here it's cruise ships. And that is coming from app.js on line 34. That is exactly where we print the data right here on line 34 with console.log. And now that we've seen fetch used in app.js, I actually want to convert getPuzzle and getCountry to use fetch instead of XML HTTP request. We're going to work on converting getPuzzle together, and you'll be converting getCountry on your own. So over in requests.js, we're not just going to be removing all of the code from XML HTTP request. We're actually also going to be removing the new promise that we create. Remember, this API didn't support promises, so if we wanted to use the promise API, we had to integrate it into the code by using new promise and manually calling resolve and reject. That is no longer the case with the fetch API, which does have promises built in. That means we can remove everything after the arrow for the getPuzzle arrow function. We can add our curly braces back in, and we can kick things off with a call to fetch. Let's set up our URL. I'm going to pass to fetch a template string, http:// the same URL, puzzle.mead.io/puzzle. And this time around, we are going to make sure to use the word count argument right here. After the question mark, setting word count equal to the correct value, which comes from the word count variable. With our fetch call in place, it's time to think about where we're going to put all of the code that we had in our standalone example down below. Here we have then twice, and we have catch. If we look at our examples up above, what we had over here is pretty similar to what we have down below with our last then and our last catch call. It is the first then call where we do the parsing and figure out exactly if things went well or if things went poorly. This is not code that I want to have to add into app.js every single time we call getPuzzle or getCountry. This is code we want to run behind the scenes over in requests.js. So what are we going to do? We're going to add a then call on right here, .then. We are going to set it up. It gets the response. We already explored that. And inside of here, we're going to add code similar to what I have highlighted over in app.js. First up, if we're going to look at response.status, checking if it is equal to 200. If it is, what are we going to do? I am going to return, and we will use response.json to return the promise that resolves with our JSON data. Now for the else, if it's not a 200, we are going to go ahead and throw a new error, much like we did in the standalone example. We can provide a message like unable to fetch puzzle. Perfect. So we have the code for the highlighted portion in its correct location. It lives in the getPuzzle function. The problem is that we don't also want this code to live in the getPuzzle function. That should live over here. So how are we going to get that done? Well, we're going to get that done by returning what getPuzzle expects. What does getPuzzle expect to be returned? Well, based off of this usage, we're expecting a promise to come back because we are using then. So to make sure that code still works, I'm going to put return up front to return our promise. Now we can turn our attention towards app.js itself. Down below, I am going to comment out our standalone fetch call, and up above, I am going to uncomment our call to get puzzle, making just a few modifications. The first thing we're going to do is adjust this function right here. No longer do we get the puzzle, instead we get our data, and then we access puzzle on data, so data.puzzle. Perfect. I am also going to take this second function and break this out using catch instead. Right here, dot catch, adding it on, and I am going to just paste the function in exactly as we had it before. Now, what do we have? We have code inside of app.js that looks very similar to what we had down below for the standalone example, and we have code in requests.js that looks very similar to what we had up above in the standalone fetch example. Let's go ahead and prove that this works as expected by saving app.js. Over here, I am getting remarkable tapestries as my new puzzle that is coming from app.js on line 16. Line 16 is the line right here where we have the console.log printing data.puzzle. All we've really done is we've taken the promise chain from below and broken it up to be in multiple locations. In this case, part of it is in a function and part of it just sits right here in app.js. Now, this process is actually the source of a lot of confusion for people who are new to promises. If you ever get confused, just think about it like this. Why can I add then onto what comes back from getPuzzle? Because what comes back from getPuzzle is all of this stuff right here. So I could just copy this code, head over to app.js and replace the call with that code. Sure, we don't have word count defined, but we can see now how everything works. What we have here is basically exactly the same as what we had down below. The only thing we've done is we've taken this portion of the promise chain and I have abstracted it behind the scenes to the getPuzzle function. Let's go ahead and make one more change to getPuzzle before we're done. Right here, instead of data, let's say that we do want what we had before, which was just the puzzle. I don't need an object, I really just want my string, so give me the string. So we're going to try to change getPuzzle to support this format. Currently, it does not. If we were to save things, we're still just printing the object. I just want a string to be resolved here instead of an object. There's one new thing we're going to learn about promise chaining that's going to make setting this up super straightforward. Over in promises.js, I want to make a small change to the example down below where we used promise chaining. I'm going to remove the string around 10 so we have valid data, and all we're going to do is change our third call to getDataPromise. What I'm going to do, instead of returning the promise that comes back from getDataPromise, I'm just going to return a string. This is some test data. Now let's save the promises file and see what actually happens when we run this script from the terminal. I'm going to run node promises.js, and when I run it, we still have to wait for our little delay to occur, but eventually we are going to see this is some test data printing. It's printing from this line down below. So what's happening here? I'm returning a string, not a promise. Why is the next then method still getting called? Well, when we're working with promise chaining, we don't have to return a promise from then. I can return anything I'd like, and that's going to get passed along to the next step in the promise chain. This can be pretty useful, not necessarily in this example where it's useless, but if we make a small change to requests.js, we can accomplish what we hoped to accomplish. Let's go ahead and move over to that file, and all we're going to do is attach another then method call right here. I'm going to set up then, and we know that this one is going to get resolved with whatever comes back from response.json. That is going to be the data. All we need to do from here is return data.puzzle, which is our string. Now the function getPuzzle is going to work with the example usage over here. I'm going to save requests.js and app.js. The browser is going to refresh. I'm getting crackling fireworks as my latest puzzle that is coming from app.js line 16. That is the line right here that prints puzzle directly. We spent a lot of time learning about promise chaining and fetch, but now it's time for you to use those tools on your own. We're going to jump into the next couple of videos, which are going to be challenge videos requiring you to actually use what you've learned here. I'm excited to get to that, so let's go ahead and jump right into the next couple videos.